Chapter 17 of The Hurricane Hunters by Ivan Ray Tannehill. This LibriVox recording is in the public domain. Chapter 17, The Gears and Guts of the Giant. He that wrestles with us strengthens our nerves and sharpens our skill. Burke. All through this book we have talked about hurricane hunters. By now it is clear that the crew on the plane that goes into the storm at the risk of destruction of the craft and death to the men is not really hunting a hurricane. It is the exception rather than the rule when they discover a tropical storm. The first hint comes from some distant island or a ship in the gusty wind circle where the sea and the sky reveal ominous signs of trouble. Somewhere in a busy weather office, a large outline map is being covered with figures and symbols. Long, curving lines across a panorama of weather take shape as the radios vibrate and the teletypewriters rattle with the international language of weathermen, the most cooperative people in the world's family of nations. Hurricane hunting is done on these maps. Day after day, without any fanfare, the weathermen search the reports spread across this almost boundless region where hundreds of tropical storms could be in progress if nature chose to operate in such an eerie fashion. Even the experienced observers on islands and the alert officers on shipboard might not see the real implications in the weather messages they prepare. In the enormous reaches of the belt of trade winds, where the tremendous energy of the sun's heat and the irresistible force of earth rotation dictate that the winds shall blow as steady breezes from the northeast, somebody might put in his report, for example, that there was a light wind coming from the southwest. That fact alone would be enough. In season, the weatherman would know almost with certainty that there was a tropical storm in the area. There are many things to watch for in the array of elements at the surface, in the upper air, the clouds, sea swells, change of barometer, faint earth tremors. A hint from this scattering of messages in the vast hurricane region starts the action, and the planes go out to investigate. This is an extraordinary procedure. Looking at it as an outgrowth of the insistent demands of citizens along the coasts in the hurricane region for warnings of these storms, as the population increased and property losses mounted, it seems that the flight of planes into these monstrous winds is justified only until a safer method can be found. All other aircraft are flown out of the threatened areas, obviously because the winds are destructive to planes on the ground. The lives of men and the safety of the plane in the air should not run a risk of being sacrificed if it can be avoided. Of course, it is argued by some men that there is a possibility that a method may be discovered to control hurricanes by the use of chemicals or some other plan requiring planes to fly into the centers. And it is true, also, that for the time being, at least, there is certain information that can be obtained in no other way. At the end of World War II, there was a grave requirement for more information about hurricanes. Little was known, except in theory, about their causes, maintenance, or the forces which determined their rate and direction of travel. Since that time, literally thousands of flights have been made into hurricanes and typhoons. Scientists have studied the detailed records of these many penetrations. We have learned a great deal in these years, but by no means enough. Herbert Real, a professor of meteorology at Chicago University, has examined as large quantities of the data as any man. Recently, he said, "Our knowledge regarding the wind distribution within tropical storms and the dynamical laws that guide the air from the outskirts to the center of the cyclone is so deficient as to be deplorable." From the scientific point of view, remarks of this kind are fully justified, but progress in the issuance of warnings is quite another matter. Hurricane prediction for the present and the near future is an art and not a science. Very great progress has been made in recent years in sending out timely warnings. There are figures to show the facts. At the beginning of this century, a hurricane causing $10 million in property damage was likely to take several hundred lives. 25 years later, the average was about 160 lives. 10 years later, 1936 to 1940 average, the figure had been reduced to about 25 and was steadily going down. After men began flying into hurricanes, the figure was reduced to 4, 1946 to 1950. This is astonishing, not only in showing how the warnings were improving after hunting by air got started, but also the big gains shortly before that time, especially after the hurricane teletypewriter circuit was installed around the coast in 1935. Experience in prediction, on-the-spot operation, and fast communications are vital. In fact, the record was so good at the beginning of World War II that most forecasters despaired of their ability to keep it up. It had consistently been below 10 lies for $10 million damage, and one serious mistake could have raised this rate considerably for several years. For this reason, as well as many others, the forecasters were extremely grateful for the information from aircraft. The main hope for greater savings in the future is that the solution of some of the mysteries of the hurricane will enable the forecasters to send out accurate warnings much farther in advance. In such an event, it will be possible to protect certain kinds of property and crops which are being destroyed at present. Heavy equipment can be moved, and certain crops can be harvested in season if plenty of time is available. These precautions are time-consuming and costly, and the advance warnings must be accurate in detail. And it will help to make sure that no hurricane different from its predecessors will come suddenly and catch us off guard and cause excessive loss of life. Now and then we have one which is called a freak. One thing we have become increasingly sure of, and it will stand repetition: no two hurricanes or typhoons are alike. Scientists may find some weather element that seems to be necessary to keep the monster going, and then are frustrated to find that not all tropical storms have it. If some can do without it, maybe it is not necessary after all. And yet all of them fit a certain direful pattern. There is nothing else that resembles these big storms of the tropics. Like the explosion of an atom bomb, with its enormous cloud recognized by everyone who sees a picture of it, the hurricane has well-known features, unlike anything else, but of such enormous extent that no one can get a bird's-eye view of the whole. Putting together what we know by radar, upper air soundings, aircraft penetrations, and millions of weather observations in the low levels, we can draw a sketchy word picture. Looking down from space, we could see it as a giant octopus with a clear eye in the center of its body, arms spiraling around and into this body of violent winds around the eye, all of the monster outlined by the clouds which thrive as it feeds on heat and moisture. We feel sure of that much. The birth of the thing has not been explained. There are plenty of times when all the ingredients are there. Nothing happens. Observation and theory flourish and swell into confusion. No scientist can say, everything is just right, tomorrow there will be a hurricane. Why it moves as it does is another grim puzzle. Ordinarily, the great storm marches along with the airstream in which it is embedded, changing its path with the contours of the vast pressure areas which outline the circulation of the atmosphere, but too often it suddenly changes its mind, or whatever controls it, or shifts gears and comes to a halt, or describes a loop or a hairpin turn. Nobody can see these queer movements ahead of time. Going out there in an airplane to look the situation over does not help in this respect. It is a vital aid in keeping track of the thing and protecting life and property, but it ends there. Where does all the air go? When the big storm begins out there over the ocean, air starts spiraling inward, and the pressure falls, showing that the total amount of air above the sea to the top of the atmosphere is lessening, even as it pours inward at the bottom. For 100 years, scientists argued that it must flow outward at the top, that at some upper level the inflow of air ceases, and above that there must be a powerful reversal of the circulation. Here again we have frustration. Going up with one of the investigators, we get the facts. Strangely enough, this is one of the men who want to get into hurricanes, who come down to the coast to look, and who finally thumb a ride with the airmen into the big winds. A brief of his story will illustrate. This story begins with the big Gulf hurricane of 1919. It came from the Atlantic, east of the Windward Islands, moved slowly to the northward of Puerto Rico and Haiti, and thence to the central Bahamas, a fairly large storm threatening the Atlantic seaboard. Then it took an unusual path, generally westward, with increasing fury. It was a powerful storm, as its central winds ravaged the Florida Keys and took a westward course across the Gulf. It happened shortly after World War I, and there was little shipping in the Gulf. The slow-moving hurricane, now a full-fledged tropical giant, dawdled in the Gulf and was lost. That is, lost as much as a monster of its dimensions can be. But its winds were felt all around the Gulf Coast, and its waves pounded the beaches as it spent 4 days out there without disclosing the location or motion of its calm center. Warnings flew all around the coast, and the week dragged to an end with the people extremely tired of worrying about it, and the weathermen worn out with continuous duty. Saturday night came, and the center seemed to be no nearer one part of the coast than another. Late at night, an annoying thing happened. It was customary in those days for the forecaster, in sending a series of messages from Washington, to stop them at midnight and begin again early the next morning. It was the rule that no reports came in between midnight and dawn. The clerk sending the last message added "good night" to let the coastal offices know that there would be no more until morning. In this case, the forecaster ended his advisory with a notice putting all Gulf offices on the alert, and the clerk added "good night." And so the offices received a message ending with these words: "All observers will remain on the alert during the night in case the barometer begins to fall and the wind rises. Good night." This created a furore in coastal cities on the West Gulf, and it was several weeks before the criticism subsided. By Sunday morning, however, the gusty wind had not risen much, and there was no great fall in the barometer, so the weathermen had no answer at daybreak. Soon afterward, however, the weather deteriorated rapidly at Corpus Christi, and hurricane warnings went up as big Gulf waves pounded over the outlying islands into Corpus Christi Bay, and the wind began screaming in the palms. Around noon, the worst of it struck the city. The tide mounted higher than in any previous storm of record, except in the terrible Galveston hurricane of 1900. Much of Corpus Christi was on a high bluff above the main business section, but the latter and the shore section to the north were low. It was after church and time to sit down to Sunday dinner when the final rise of the water began to overwhelm everything. The police sent out by the Weather Bureau were knocking on people's doors and telling them to get out and run for high ground. But these low sections had survived a big, fast-moving hurricane 3 years before without nearly so high a tide, and most people thanked the police but determined to stay and eat. This decision was fatal in the North Beach section. The road was cut off, and nearly 200 were drowned. Down on Chaparral Street lived a man named Clyde Simpson with his wife and 7-year-old son Robert. The boy's uncle and grandmother were there also. They were about to sit down to a big platter of chicken, and the boy had his eye on a pile of freshly fried doughnuts. They had been out standing with other nervous people to look at the great waves roaring across the beach, but after a little the storm waters had forced them back and covered the streets. Now the water was rising fast. Several houses had come up off their foundations. A large frame residence on the opposite side of the street floated across, and while they held their breath, missed them by a few feet, struck the house next door, and both collapsed. The elder Simpson said it was time to get out, dinner or no dinner. The family went through the backyard, the nearest route to higher ground. The boy's mother put the dinner in a large paper sack and held it above her head as she struggled through the water. The father carried the 7-year-old on his back and brought up the rear, swimming a little as the water continued to rise. The grandmother, an invalid strapped in a wheelchair, was pushed and floated ahead by the uncle. The boy worried as his mother got tired and let the paper sack hang lower and lower. Finally it hit the water, and the chicken and doughnuts sank or floated away. That scene was etched in Robert's memory, along with the battering of the winds and the tremendous rise of the waters over the stricken city. The family survived. Looking out of the windows of the courthouse on the edge of the bluff above the business section, the boy watched others struggling toward higher ground. Afterward, the family returned to their house, smeared with oil and tar, and by dirty water, floors covered with sand, mud, and debris. Robert saw death on every hand, dead dogs, birds, cats, rodents, and one neighbor who failed to get out. In 1933, when one of the hurricanes of that year crossed the Gulf and threatened the lower Texas coast, much like the big one in 1919, a young fellow drove all the way from Dallas to have a look at it. He was Robert Simpson. He never got it out of his mind. Finally, he joined the Weather Bureau, worked at hurricane forecasting offices, and in 1945 thumbed his first ride into a hurricane. After that, his enthusiasm and persistence annoyed some of the older weathermen and bothered members of the air crews who flew the big storms, both in the Atlantic and Pacific. Simpson made up his mind that he would use every opportunity to find out how the big storms were organized and what they were geared to in their movements, regular and irregular, the gears and guts of the thing. When Milt Sosin lurched into the center of the big storm in 1947 in a B-17 and looked up to see a B-29 high in the eye of the same hurricane, Simpson was up there with the men from Bermuda trying to find out what steered the monster. And on this flight with the B-29 they expected to come out on top at 28 to 30,000 feet, according to the theorists and the textbooks. But they broke out just below 40,000, still 100 miles from the center. From there, the high cloud sheet should have sloped downward to the center if they were to believe the accepted doctrine of circulation in the top of the hurricane. But they were shocked and chagrined to find that the high cloud sheet, the cirrostratus, sloped sharply upward in front of them, rising far above the extreme upper operational ceiling of the B-29. And so the superfortress turned toward the center and rocketed into the high cloud deck with misgivings on the part of pilot Eastburn and Simpson. The latter reported, "Through this fog in which we were traveling at 250 miles an hour, there loomed from time to time ghost-like structures rising like huge white marble monuments through the cirrostratus fog. Actually, these were shafts of supercooled water which rose vertically and passed out of sight overhead as we viewed them from close at hand. Each time we passed through one of these shafts, the leading edge of the wing accumulated an amazing extra coating of rime ice. This kind of icing would have been easy to shake off if the plane had been fitted with standard de-icing equipment, but it was not. We were so close to the center of the storm by the time the icing was discovered that the shafts were too numerous to avoid. Pilot Eastburn punched me and pointed to the indicated airspeed gauge. It stood at 166. "At this elevation, this plane stalls out at 163, Eastburn said, "and in this thin air there is no recovery from a stall." He continued, "We have got to get out of here fast." I nodded agreement, feeling a little sheepish about the whole thing. After all, hadn't Vincent Schaefer of General Electric, just a few months earlier, demonstrated in the laboratory that water vapor could be cooled to a temperature of -39 degrees before freezing set in? But in the turbulent circulation of a hurricane, this was fantastic, unbelievable. But there certainly was no guesswork about that 6 or 8 inches of rime ice on the leading edge of the wing. We got out of there all right, and fast, but we had to do it in a long, straight glide. The plane was simply too loaded with ice and too near stall out to risk the slightest banking action. After all, the atmosphere is a mixture of gases, and it obeys the laws of gases. If the scientists assume that the big storm has a certain structure and a certain circulation of air in its colossal bulk, there are definite conclusions to be drawn concerning the physics of this giant process in the tropical atmosphere. But if it turns out that the assumptions about the structure and circulation are wrong, the conclusions of the physicist may be exactly opposite to the truth. The results of years of study, calculation, and discussion seem to be overthrown in one moment as a superfortress plunges into a vital section and the crew sees things that ought not to be there. Most important in the 1947 storm was the fact that conditions at a height just below 40,000 feet were such as to go with the circulation against the hands of a clock at maybe 130 miles an hour. The plane going in that direction had a tailwind of 90 miles an hour, and yet the students of hurricanes during the past century were sure that at some height well below that level, the winds blew outward in a direction with the hands of a clock. In agreement with this conclusion, most of the scientists had made up their minds in recent years that the circulation in the lower part of these storms usually disappears at 20 to 30,000 feet. And so, if we are to account for the removal of air in this great space extending down to the sea surface, it must have been done well above 40,000 feet in this case, and up at this height the air is so thin that it is almost inconceivable that it could blow hard enough to account for air removal in the average hurricane. On the other hand, this was a mature storm, and it may be that at this stage no air was actually being removed from the system, and that the gigantic circulation of the full-grown monster is self-contained. While it would be extremely interesting to understand the magic by which nature so slyly removes the air from the hurricane under our very noses, the practical question is whether or not its escape at the top is geared in any way to the forward motion of the main body of the storm. The answer to the first question may give the answer to the second, and possibly also to the third question: what causes a hurricane to increase in intensity, to deepen, as the weatherman says, having reference to the fall of pressure in the center? He thinks of it as a hole in the atmosphere. This 1947 hurricane illustrates the great difficulty of finding answers to our questions. But in any case, this was just one storm, and all of them are different in one way or another. But to go back to the story of the guest writer from the Weather Bureau, Robert Simpson, the story is not complete without a brief account of the flight into Typhoon Marge. It raised its ugly head in the Pacific in August 1951, and on the 13th had passed Guam, a storm not well developed, but of evil appearance, showing signs of growth. That evening, Simpson arrived from Honolulu, where he was in charge of the Weather Bureau office. He accepted an invitation from the Air Force to visit Marge, and on August 14, 6 hours after he alighted from Honolulu, was airborne in a B-29 and on the way. In a few hours, Marge had grown into a colossus. It was nearly 1,000 miles in diameter, with winds exceeding 100 miles an hour in an area more than 250 miles in diameter. When the hurricane hunters entered the center and measured the pressure, it proved to be one of the deepest on record, 26.45 inches at the lowest point. From plane level, the eye was perfectly clear above, 40 miles in diameter, and circular. The massive cloud walls around the eye rose on all sides to 35,000 feet like a giant coliseum. The west wall was almost vertical, with corrugations that suggested the galleries of a gigantic opera house. In the center, below the plane, they saw a mound of clouds rising to about 8,000 feet, an unusual feature, but one that has been observed in other tropical storms. The crew spent 14.5 hours in the central region of this huge typhoon, getting data at levels from 500 feet up to 20,000. Down in the lower levels, they found a horizontal vortex roughly 5,000 feet in diameter, extending from the cloud wall of the eye like a tornado funnel, in which they encountered very severe turbulence. Another collection of data was added to the growing accumulation, and with it the notes of unusual phenomena observed. Since that time, Simpson has flown several hurricanes in the Atlantic. Now, it is abundantly clear that the hurricane hunters are looking for many important facts aside from the location of the tropical storm and a measure of its violence. There are many questions unanswered. Here, in the warm, moist winds that blow endlessly across deep tropical waters, there are mysteries that have challenged man for centuries. Turning to their advantage every discovery that science has pointed in their direction, the hurricane hunters have cheated the big storms of the West Indies of a very large share of their toll of human life. In struggling to solve the remainder of the problem, they have two virtues that will ultimately bring success: ingenuity and persistence. They push on tirelessly in several hopeful directions. The Navy has taken advantage of the strange fact that when a tropical storm comes along, it literally shakes the earth. There are little tremors like earthquakes, but very much smaller. The Greek word for earthquake is seismos, and by putting micro in front, meaning very small, we have the word microseism. And so the storm-caused little tremors are called microseisms, or slight earthquakes. The instrument which registers these tremors is called a seismograph. When the earth moves even a very little, a body on the earth tends to hold its position, and the earth moves under it. In a small earthquake, a chair will move across the floor. This kind of motion can be registered by instruments. In 1944, the Navy installed seismographs and began keeping records of the slight tremors caused by hurricanes and typhoons. These studies have shown that a tropical storm at a distance produces a small tremor, which becomes stronger as the storm center gets nearer. No one knows exactly how the storm shakes the earth and causes the tremors. There are some strange things about this. It seems that these microseisms are carried along in the earth until they come to the border of a great geological block and then do not pass readily into the next block. So there are places in the Caribbean where the tremors weaken as they come to a different earth block, and this interferes with the indications picked up by the instruments. The fact is that microseisms give signs of the existence of a tropical storm and sometimes serve to alert the storm hunters, but they are by no means good enough to replace the use of planes in tracking them. But the studies of microseisms are being continued. For many years, static on the radio, better known as atmospherics or just spherics, has been used in the endeavor to locate or keep track of storms. At first, the Navy tried it on West Indian hurricanes. The instruments used will find the direction from which the spherics come when they are received in a special tube. In more recent years, the Air Force has used this scheme. It works to advantage in finding thunderstorms, but tropical storms are so big and the spherics are not found in any regular pattern around the central region. After years of trial, it has been concluded that this scheme is not good enough to replace other methods. Of all the methods of this kind, radar is by far the best. But as the radar stations on shore and the radar equipment on aircraft have increased in numbers and have been improved to reach greater distances, some new troubles have arisen. For many years, the hurricane hunters took it for granted that a hurricane has a clear-cut center which moves smoothly along a path that is a straight line or a broad curve, but in a few cases is a loop or a sharp turn. In other words, the center does not change size and shape or wiggle around. In the past, when an observer on a ship or on a plane reported a center of an odd shape, or had it off the smooth path the hunters were plotting, they said the observer had made an error. Now, as the hunters have begun watching hurricane centers close by on the radar, they see them changing shape and wiggling around. In fact, as stated in a few cases in earlier chapters, they have seen false eyes and have been confused by them until the true eye came into view on the radar scope. If the true eye describes a wiggly path and changes size, the hunters can draw the wrong conclusions about its direction of motion unless they wait a while to see if it comes back to the old path. The hurricane is a little like an eddy or whirl in water running out of the bottom of a bowl. It is a violent boiling eddy that twists and changes shape, and in a substance as thin as the atmosphere, these motions are not steady to such a degree that the observer can reach a quick decision. At any rate, it is now apparent that the observers on ships and aircraft did not make as many errors as was thought several years ago. There is another aspect that must be kept in mind. Radar shows areas where rain is falling around the center of a hurricane, and so the center, having no rain, stands out as an open space on the radar scope. This is very good if the storm has rain all around the center, but some of them have very little rain on the southwest side, and in some cases there is none to return an echo to the radar. In such a case, there is only one side to the storm echo, and the location of the center is not revealed. Of course, these facts are known to the experienced radar men, but they should be known to everybody interested in hurricane reports. Otherwise, they are likely to expect too much accuracy from observations of this kind. For these and other reasons, the man on the aircraft has a very great advantage in daylight, for he can see clouds of all kinds, measure the winds, and by moving through the storm area at the speed of the modern airplane, he can see a large part of it in a short time. To find a substitute for aircraft reconnaissance is going to be extremely difficult. But at night the situation is quite different. The airman is unable to see much without radar, except on a moonlit night, and that is not very good. One suggestion that has been put forward by a number of different people in recent years is that a balloon be flown in the calm center and followed by radar or radio, thus keeping track of the storm's motion. It is possible, of course, to fix a small rubber balloon, perhaps 8 to 10 feet in diameter, so that it will remain at the same height for a fairly long time. By one method, the rubber balloon is partly filled with helium and covered loosely with nylon. The balloon expands as it rises, becoming less dense as the atmosphere gets thinner. It continues to rise until it fills the nylon cover and cannot expand further. After that, its density becomes the same as the air at some level previously chosen, and from there it drifts along without rising or descending. It is the idea that the obliging balloon would drift here and there in the vagrant breezes of the eye, but when it came to the edge of the powerful wind currents around the outside of the eye, it would be guided back in. No experiment has been carried out to prove that this would happen, but such trials have been scheduled and will be made at the first opportunity. There is one difficulty. The question is how to get an inflated balloon into the center and release it under proper conditions. One of the men who has worked on a scheme of this kind is Captain Bielinski, the Air Force officer who broke his $100 watch in a typhoon and solemnly swore he would find an easier way to do it. He calls his device Typhoon Homer. He has worked on it for 4 years, spending much of his own time and money. There are reasons to believe that after a few experiments, a height could be found where the balloon would stay in the eye. So far as we know, birds trapped in the center are held there. After battling hurricane winds, they are so exhausted on getting into the center that they could not remain there if the wind circulation tended to suck them out into the surrounding gales. Bielinski concluded that the balloon could not be thrown out from a plane in even a partially inflated condition. The blast of air on leaving the aircraft would destroy it, or put it out of commission. So he has an uninflated balloon and bottles of gas, a small radio transmitter, and a float, all attached to a parachute. The bottles and radio would be thrown out, the parachute would open, and the gas would go through a tube from the bottles into the balloon. The float, with a long line to the balloon, would rest on the water and provide an anchor for the apparatus. The radio would send signals every hour. The operators on shore would figure its location by direction finding, and there would need to be no further aircraft flights into that storm. The device, according to Belinsky, would continue to operate for 7 days. Robert Simpson and others have had similar ideas, some favoring a device that could be followed by radar, but Simpson prefers the radio transmitter. To find out how the weather circulation in the calm center would affect the balloon, he planned experimental flights in hurricanes to release a chaff made of a substance that could be followed by radar. He tried it in 1953 and again in 1954, but something happened in each case to prevent the experiment from being carried out. In one case, for example, nearly everything was in readiness for an experimental flight to take off when Edward Murrow of CBS arrived in Bermuda with his crew and apparatus to put Hurricane Edna on television, and Simpson was moved to the back of the plane. He and all others connected with it, including Major Lloyd Starrett, who had been brought in from Tinker Air Force Base to work with Simpson, were glad to make way for a public service program. But this shows one of the reasons why developments of this kind, which depend on opportunities in only a few hurricanes a year, take a discouragingly long time. There was no chance to test Belinsky's device, or any other for that matter. There have been laboratory experiments also on a device to deflect the airstreams around the bomb bay of the aircraft so that a partially inflated balloon could be safely released in the eye of a storm. These devices are mentioned here to show the trend of thought. Something similar to this may eventually serve to replace a large share of the hazardous aircraft flights, but even if the center is satisfactorily located in such a manner, much useful information on the size of the storm, the force of its winds, and other data will be determined in many cases only by aerial reconnaissance. With this in mind, both the Air Force and Navy are substituting bigger and better aircraft for this purpose. The old B-29 Superfortress is being put out to pasture, as they say in the Air Force. The higher, faster, and farther flying Boeing B-50s are replacing them, not only in hurricane reconnaissance, but in the daily flying of weather routes to help fill in the blank spaces on the world's weather charts. The B-50s will go 10,000 feet higher than the B-29s. Another advantage that appeals to the hurricane hunters who fly on these missions is the electric oven, standard equipment on the B-50, which will furnish hot meals at favorable times on the route, instead of sandwiches and thermos coffee. The Navy, not to be outdone, is coming out with the Super Constellation, which is being modified for hurricane reconnaissance to replace the P-2V Lockheed Neptune recently used. As each new season comes, the hunters are wiser and better equipped. The battle with the hurricane is joined. It is something to worry about, like war and the H-bomb. At the end of the 1954 season, the executives of the big insurance companies were in conference with grave faces. Property damage from Carol, Edna, and Hazel had mounted upward to around $1 billion. Reports have been circulated to the effect that the slow warming of the earth in the present century is bringing more hurricanes with greater violence and paths shifted northward to devastate areas with greater populations. There was speculation about the effects of A-bombs and H-bombs on hurricanes. All this trouble comes from water vapor in the atmosphere. Without it, the earth would be a beautiful place, but useless to man. Even over the tropical oceans, it rarely exceeds 5% of the bulk of the air. In other regions, it is much less. But it is this vapor, constantly moving from the oceans into the air and spreading around the world, that builds the stormy lower layer of our atmosphere, the troposphere, where clouds and storms, snow and ice and torrential rain, thunderstorms, hurricanes, and tornadoes thrive in season. Such tremendous energy is needed to carry billions of tons of moisture from the oceans to the thirsty land that all of these rain and storm processes are maintained on the borderline of violence. Here, at the bottom of the atmosphere, the vapor absorbs the heat radiated from the sun. There is a swift drop in temperature as we go aloft. Moist air pushed upward becomes cooled, and ice crystals, water droplets, snowflakes, are squeezed out. Clouds form, beautiful in the sunset, gloomy on a winter day, threatening as the summer thunderstorm shows on the horizon, fearsome as the winter blizzard takes command of the plains and valleys. Here is water vapor coming to the end of a long journey from the surfaces of distant seas. From here it goes to the land and begins another long journey in the rivers and back to the oceans. But on the way to us, violence may be one of the principal ingredients. We can't live without it, and we have trouble living with it. When this lush flow of water vapor from the tropical ocean to the atmosphere becomes geared in some special manner to swiftly moving air from other regions, the process seems to get out of nature's hands. Upward motion begins on a grand scale. Converging streams of air are twisted by the spinning of the earth on its axis. And just as men begin to see the picture, nature draws a veil by the condensation of water vapor. Under this darkening canopy, violence grows with startling swiftness. The water vapor that drew the curtain now releases energy alongside of which the A-bomb shrinks to insignificance. Far below the sea surface, the solid earth trembles. Avalanches of water are torn from the ocean and hurled down the slopes of the gale. A colossal, darkening storm begins to move across the ocean. It sucks inward the hot, moist lower atmosphere and brings it along with it, using the vapor to feed its monstrous, seething cauldron. Down here, at the surface of the earth, its winds are warm and humid. Its tentacles, octopus-like arms, reach out with gale-driven torrents of rain and begin picking everything to pieces. After hours that seem like days, the central fury of the earth-blasting storm begins its devastation of man's possessions. And as it has proved to be unquestionably true that no two hurricanes are exactly alike, so it is evident now that the same hurricane is subject to massive changes from day to day. It has a life history. Like the caterpillar that is transformed into the cocoon and then into the butterfly, the tropical storm goes through definite stages. The problems involved for the hurricane hunters in each of these distinct stages demand separate solutions. Like a living thing, the monster has infancy, youth, middle age, and decline. In infancy, its malevolent forces are directed vigorously toward the mysterious removal of large quantities of air from above its gale-swept domain. The excessive heat and moisture of its birthplace yield far more energy than is needed to keep its mighty, low-level winds in motion. In youth it is extremely violent, and the removal of air brings exceedingly low pressure into its center. Its outer parts become ominously visible through the condensation of moisture on a grand scale, cloaking its internal mechanism. Its destructive forces spread. In this stage, the removal of air in upper regions continues in excess of the inflow at the bottom in proportion to the horizontal expansion of the system. In middle age, its violent forces are directed toward maintenance of the colossal wind system. The total energy it can derive from heat and moisture no longer produces an outflow above in excess of the inflow of air at the bottom. It expands in the vertical, and its visible parts push against the stratosphere. As it moves farther away from its birthplace and the available energy begins to decline, it dies. For a few days, nature's processes for the transport of moisture from the oceans to the thirsty continents have run amok. Life and property suffered while torrential rains fell. So it is clear that in life the monster thrives on heat and water vapor. Down at sea level it is a warm phenomenon. Only the heated air of the tropical regions can hold enough moisture to feed the giant. But up above, the full-grown hurricane is not a warm storm. Hunters perspire at low levels, but not in the top of the storm. There are icy corridors through currents of air robbed of their heat by the monster below. Pillars of supercooled water push upward into the thin atmosphere. Snow flies with the shuddering winds at the top of the troposphere. It is colder up here above the tropics than it is above the poles. The fingers of the gale tremble with the cold and seem to make gestures in defiance of the sun shining through the stratosphere. Water vapor in great quantities has been carried high in the atmosphere, and nature seems powerless to bring equilibrium until land or cold water at the earth's surface below shuts off the abundant supply of energy. And when it does, the monster dies as it was born, hidden behind a veil produced by lingering cloud masses derived from the vapor that gave it life. In the last few years, men have had the courage to fly into these monsters. Some day, when other methods are used, people will look back in amazement at these brave events. Here they can see how it happened, how it was done, and feel admiration for the men who did it, the hurricane hunters. End of chapter 17.